In this lesson, we're going to learn a new vocabulary word and learn about them. The vocabulary word is an isometry. Okay, an isometric transformation, or an isometry, is a transformation that preserves distance and or angles between the preimage and the image. Okay, so we're going to be taking a look at different transformations that are isometric, and we call them isometries, or we call them a rigid motion. All right, so an isometry is a rigid motion. It's the same exact thing. It's two different things. You're just calling it two different things. So when you hear isometry or isometric, it's the same exact thing as if you heard rigid motion. All right, so keep that in mind. In simpler words, an isometric transformation maintains the shape and size of the preimage. So, very simple. If the shape and size remain the same, we have a rigid motion, which is called an isometry. Okay? So again, same size, same shape, it's an isometry, it's a rigid motion. That's what you have to memorize. So here's some examples for you. All right, example 1, 2, and 3 up top here. Okay, so here's an example of a rotation that is an isometry, because the blue one going to the gray one, it's just turned, right? So that's a rotation. That is an isometry. That is a rigid motion. Example 2, the purple to the gray. All it did was slide over. That's all it did was slide over. That's called a translation, and that's just a slide, and that is also an isometry. And the third one, blue to green, it just flipped over. Size and shape did not change. Size and shape did not change. Therefore, that is an isometric transformation as well. Here are examples of some non-isometric, non-rigid, non-isometric, meaning either distance or angles have changed. If you look at example 1, purple to gray, it got bigger. The size changed. Non-isometric, non-rigid. Got it? In the second one, the size changed, but because it was stretched out. That small triangle got stretched out. That's a stretch. That is non-isometric. That is not rigid. And then in example 3, the shape got changed. It became a square to a rectangle, and it's not proportional, so it can even be thought of as a stretch. Okay, but anyways, the shape changed, and therefore it's stretched, and therefore it is a non-isometric, non-rigid. Okay, so stretches and dilations. Stretches and dilations are not going to be isometric. Reflections, rotations, translations, those are all isometric, and those are all rigid motions. Example 1 here, circle which of the following are isometric transformations. So what happens? So here's the preimage, just to make sure we understand what we're talking about here. Here's the doggy preimage, and here's an image here. So it's A, B, and C, multiple choice basically. So in the first one, determine is it isometric or not. They want us to circle isometric. So in A, is it isometric? Well, no, because the doggy got smaller, right? So it's a dilation, therefore, no. So this is a dilation, non-isometric, okay? How about this one? The doggy stretched. The picture stretched. Again, it's a stretch. So it is non-isometric, non-rigid. We're not going to circle it. How about this guy? Doggy is exactly the same, except doggy rotated. Okay? Doggy rotated, same size, same shape. He's just going to sleep, laying down, right? Same exact, everything's same size, same shape. All right, so this is a rotation. And this is isometric. It's isometric because it's the same size and same shape. All right, so we are going to circle doggy C. Hope we're understanding this a little better. How about this guy? How about here's doggy pre-image, right? Doggy pre-image. Use this previous example to determine which transformation took place. Oh, we already did it. Okay, so the first one was a dilation, the second one was a stretch, and the third one was a rotation. All right. So here we go. Circle which of the following are isometric. All right, so pre-image is right here. That's the pre-image. We're not circling. I'm just trying to highlight it for you. All right. So A, B, or C? Well, A, same image, just rotated. So yes, that is isometric. Try these before you watch the video, guys. Image, this one here, same size, same shape. It just flipped. He flipped around. It's a reflection. Isometric. This guy, little baseball player, was stretched out, so that is non-isometric. So we're not going to circle him. All right, so this one here was a rotation, and then this one here was a reflection, and then this guy here was a stretch. And we didn't circle him because it was non-isometric. Hope we're understanding a little bit. And we're going to do a couple more examples, and then we're done. So what happened here? So what we want to do is take our pre-image points, here they are, and we want to do the coordinate rule x negative y. So xy becomes x negative y. So x becomes x, that means we're not going to change the x. So x is -1, x is 0, x is 4. We're not going to change our x. What happens to the y? Y becomes -y. That means change the sign of y. So we have 1, it becomes -1. We have 4, it becomes -4. We have 1, it becomes -1. So we have A prime, B prime, C prime that we're going to graph over here. -1, -1, 0, and that's A prime, we got to label it. 0, -4 is B prime, and then 4, -1 is C prime. So we have our new triangle. Notice how if you compare it to this one, okay, it's the same size and same shape, so yes, it is an isometry. All it did was what? It flipped over. If you graphed it on the same graph, actually, you would see better. It just flipped over the x-axis. So it is a reflection. It is a reflection. All right. And then this last one here. Here's the rule. X again stays the same. Y becomes -2y. So you basically multiply times -2. 0 times -2 is 0. 3 times -2 is -6. You have to listen to the explanations. 3 times -2 is -6. And then 0 times -2 is 0. So watch what happens. 0, 0. 1, -6, 1, 2, 3, 4, 5, 6, that's a little bit off the graph, and 5, 0, 1, 2, 3, 4, 5. Now, look what happened to triangle ABC when we do A prime, B prime, C prime. It changed. It stretched. Instead of being here, B went, it flipped and stretched, actually. It flipped and stretched. All right, so the transformation type is a reflection and a stretch. Now, it did two different things. But the bottom line is there's a stretch. If there's a stretch involved, it's not isometric. So no, it is not isometric. All right. So that's it for this lesson. We're going to practice this kind of stuff in class tomorrow. We'll see you then.